In bitwise operators, if we talk about bitwise and operator, that is represented with single ampersand. If two bits, that is if bit 1 is 1 and bit 2 is 1, then the output will be a 1 bit. If bit 1 is 0 and bit 2 is 1, or if bit 1 is 1 and bit 2 is 0, or if both the bits are 0, then output would be 0. So this is what bitwise and. In logical AND operators, we have seen if both the boolean values are true, then output will be a true. Similarly, here if both the bits are 1, then output will be 1, and in remaining all the cases, output is 0. Suppose let us take two integer values, that is 5 and 3. Suppose if we want to convert this 5 into bits, then we need to divide with 2, that is 2 to the 4, remainder is 1, and 2 ones are 2, remainder is 0. So if we write this way 1 0 1, so this is the bit representation of value 5. And similarly for 3, 2 ones are 2, remainder is 1, and here if we write in bit representation, it will be 1 1. So here we can put 0. Okay, now these are the two bit representation of values 5 and 3. Now if we perform this bitwise AND operation between these two bit representations, that is 101 and 011. Now if we perform bitwise AND operation, so as I said here, if both the bits are 1, then output would be 1, and in remaining other cases output is 0, right? So here we have 1 1, so output would be 1, and here we have 0 1, so output is 0, and here we have 1 0, so output is 0. Now if you want to represent this bit representation into a number, it can be written as, so here we need to put 2 power 0, 2 power 1 and 2 power 2, and we need to multiply this 0 with this number, and we need to multiply this 0 with this number, and we need to multiply this 1 with this number, and then we need to perform addition. So here 1 into 2 power 0 is 1, plus 0 into 2 power 1 is 0, plus 0 into 2 power 2 is 0. So output would be 1. So the answer for bitwise operation for the integers 5 and 3 is 1. So this is how we need to perform a bitwise AND operation. Similarly, if we consider bitwise OR, which is represented with single pipeline, and in bitwise OR operator, if bit 1 is 0 and bit 2 is 0, then the output would be 0, and in remaining other cases output is 1. That is, if bit 1 is 1 and bit 2 is 0, or if bit 1 is 0 and bit 2 is 1, or if both the bits are 1, then output would be 1. So in logical OR operation, we have seen if both the boolean values are false, then output would be false. Similarly, here if we talk about bitwise OR operator, if both the bits are 0, then output would be 0 bit, and in remaining other cases, that is if one of bit is 1 and if both the bits are 1, then output would be 1 bit. So this is what about bitwise OR operator. Suppose if we consider integer 5, so if we denote this 5 with bit representation, so it gives us the 101 we have seen in previous, right? And if we take 3, which is an integer, and if we write with a bitwise representation, it gives us 011, so that is 101 and 011. And if we perform bitwise OR operation, so here we have in bitwise OR operation, if both the bits are 0, output would be 0, and in remaining other cases output is 1. So here we have 1 1, so output is 0, and here we have 0 1, so output is, sorry, here we have 1 1, right? So output would be 1, and here we have 0 1, output is 1, and here we have 1 0, output would be 1. So here 2 power 0, 2 power 1, 2 power 2. So 1 into 2 power 0 is 1, 1 into 2 power 1 is 2, 1 into 2 power 2 is 4, and we need to add. So it gives us the 7. So this is the value for the integer values 5 and 3. So this is how we need to perform bitwise OR operation. So in bitwise OR operation, if both the bits are 0, the output would be 0, and in remaining all the cases output is 1. And when we talk about bitwise XOR operator, if any one of bit is 1, then output would be 1. Suppose if bit 1 is 1 and bit 2 is 0, or bit 1 is 0 and bit 2 is 1, then output would be 1. And if both the bits, that is bit 1 and bit 2, are same, either both the bits are 0 or both the bits are 1, then output would be 0. So if any one of the bit is 1, then output would be 1, and if both the bits are same, then the output would be 0. This is about the bitwise XOR operator. So suppose if we take 5 bit representation, that is 1 0 1, and if we take 3 bit representation, that is 0 1 1, and if we perform XOR operation, that is XOR operation, here in XOR operation we have seen if any one of the bit is 1, then output would be 1, and if both the bits are same, output is 0, right? So here we have both the bits are, here both the bits are same. So as I said, if both the bits are same, output would be 0, and if both the bits are different, output would be 1. So here both the bits are 1, that are same, so output is 0, and here both the bits are different, so output is 1, and here also both the bits are different, so output is 1. Now in order to represent this bit representation into an integer, we need to multiply 2 power 0 into 0, 2 power 1 into 1, 2 power 2 into 1, and then add. So 0 into 2 power 0 is 0, and 1 into 2 power 1 is 2, and 1 into 2 power 2 is 4, and then we need to add. So 4 plus 2 is 6, 6 plus 0 is 6. So the answer for bitwise XOR between 5 and 3 is 6. So this is how we need to perform bitwise XOR operation. So if both the bits are same, output would be 0, and if both the bits are different, then output is 1. So this is what about XOR operation.